Welcome to the Last Mile Delivery Podcast, your front row seat to the technological advancements shaping the future of last mile logistics. This podcast includes recordings from our Last Mile Delivery meetup, offering you exclusive insights and discussions about the cutting edge of the final mile in logistics. If you are interested in finding out more about upcoming events, technological updates, and industry news, subscribe to the Bettermile newsletter. The link is in our bio.
It's so great to see you all here. Thanks for coming. This is our second last mile delivery meetup, hosted by Bettermile. The delivery industry continues to be in motion. You can read it every day in the news. You can read it every day on LinkedIn. More than ever, it's necessary that we talk about the topic how to build a parcel delivery service as a tech product. This format is designed to bring together people from established delivery players, neo companies that just joined the market, and tech providers that offering their services. Welcome to the Last Mile Delivery Meetup. It's great to see you all here. Give yourself a hand. So, I brought some screenshots or photos from our last meetup. End of November, we talked about operations control. You remember? How to bring tech involved and control our operations. The learning that we took was that digital products are a lot about user experience, but they also have to be about productivity. Sometimes even a little bit more about productivity. But productivity has to feel right? For the consignee, for the delivery drivers. We learned about how it's essential for the delivery partners as a dedicated target group. Thanks to all of you guys to making this last event a success and the fruitful exchange that we had. And to be honest, operations control, you all know in the last couple of weeks and months, we had to learn the hard way, how important this topic is. Companies like Drop filing for insolvency. Companies like Instabox giving up their operations in Netherlands. This was for sure not because delivery experience was not good. This was because of this massive flywheel of operational cost in parcel delivery that has to be watched. So we had the right topic at the right time, and it proved us this exchange that we have here is more important than ever. So this event is all about creating a community and contribute to an exchange about topics like these, about hands-on experience and exciting tech insights. And let's be honest about this. We all that we are here and all those remote joiners, we need this exchange. We need this exchange not just to open our mind. We need this exchange to meet each other and file partnerships and cooperations. Those of you guys who have been longer in this industry know this effect well. When one parcel delivery company meets another one, they see each other as competitors. And we tend to not talk about anything because we could lose our market position or USP or whatever. But we also know that this is not the truth. The parcel delivery companies to each other are not solely competitors. We are under threat all parcel delivery companies are under threat to be platformized by big tech. They are probably the real competitors. And this is the reason why we, from a strategic perspective, we may all have, all parcel delivery companies, all tech providers, they may have their market position, their certain more premium, a little bit more economy service. They may have their customers and their special services. But we need to partner. We need to cooperate to prepare for the real competition. Thanks for joining today. We have more than 650 participants. 100 of you coming here on site. Thanks very much for joining, and glad to have you at the networking session later on. We have 550 remote then. Had to do some math, sorry. From 400 organizations and representing 25 countries. So really exciting to have you all here. If we look at the list, hey, DHL joined, right? We missed them last time, didn't we? So that's great. Give DHL a hand. GLS, Hermes, DPD, Amazon Logistics, they're all here. Proud to have Venipack, like the rising star in Lithuania, Estonia, and Latvia. So really exciting to have you guys here. So a lot of things are going on, especially in Eastern Europe, but also Southern Europe, Central Europe. It's really exciting. We have the rising stars, the startups, Instabox, Urbify, locally, also in person here today, the Liefergrüns, but also from food and grocery delivery representatives. And we have e-commerce companies, they start building up their own delivery fleets. Really exciting. And why do they do this? They want to own the delivery experience. Isn't this great? Right? So putting the parcel companies under pressure, that's exciting. But remember, we need to partner. Right? Okay. And the tech providers. And yeah, glad to have some infrastructure providers, new providers here. Mapbox here is here. Zebra just joined us as one of the major rugged devices providers. So in hardware, not only for logistics, but also beyond. So really excited, and there will be great talks we'll have also in the networking session afterwards. So we are glad to be your hosts tonight here at Bettermile. Hope you like the better space. For those who joining online, please come by next time if you can make any chance and meet us in person. Yeah, for those who don't know Bettermile, we are a software as a service provider for parcel logistics. We have 3 pillars of our product. It's about dynamic sequencing and driver navigation in the core. We have machine learning and consignee communication tools that enable live tracking, real-time tracking, how we call it. And thirdly, we are active in address processing and address intelligence. That will also be part of our topic today. So that's what we do. Some description, we are not a platform, right? So delivery platforms enabling like with full scope business logic, etc. We are providing software as a service components for delivery companies who have their own transport management system, their own ERPs, and they can enrich their existing services to leverage user experience and productivity. Hey, come, some advertising is okay for tonight, right? Okay, cool. But so far for it. And the topic for today is very exciting. Our focus topic is geospatial, the magic of location in the last mile. Some questions to you guys. Have you ever delivered a parcel yourself as a delivery driver and you were sent to the wrong location? This really sucks, right? Have you ever tracked a parcel and you saw in the live tracking that what the pin on the map is not really the location where you are, and this is being sent to the wrong location, you don't know where this is going? This sucks a lot, right? Have you ever seen an estimated time of arrival that was 2 or 3 hours off because they took the wrong location to calculate it? Have you had trouble finding the better space in the second courtyard? Aufgang B, 4th floor? Or would you have needed a precise location to find the door? This is why we're talking, and you can feel it. It makes the difference in productivity, and it makes a difference in user experience. So it's more than important than ever. It's the groundwork for what we do, and we better do it right. Really proud to have 4 fantastic speakers today. Hot topic, hot speakers, right? So back. Yeah, okay. Octavio Herrera. He has worked in address processing for over 3 years now. He's product owner for the Better Places product at Bettermile. He came across the variety of challenges of normalization and geocoding. He learned the industry specifics, and I can truly say the hard way, the tough way. So really excited to hear about the experience. Welcome, Octavio. Give him a hand. Welcome, David. With over 6,000 vehicles and 620 depots and agencies in Spain and Portugal, GLS maintains one of the strongest delivery networks in Iberia. David is Chief Digital Officer and driving the digital efforts of GLS Iberia on this subcontinent. And he will today talk about his use cases, their use cases, where they're dependent on geolocation. Really excited to hear about it. David, thanks for coming all the way from Barcelona. With over 1 billion parcels per year, they hardly forgive any errors in address and location data. The productivity, the user experience has to be right. Alex, as head of last mile development at Hermes Germany, works at the forefront of this challenge. We're really glad to have him here representing another established player in the industry. Excited to hear about your experience. Give Alex a hand, please. Ingo Boegemann, as co-founder of Berlin-based startup Truemetrics, he's working on the future of location data and telling us that this goes beyond lat-long GPS geolocation values. They're using motion detection and machine learning to close the gaps of location data in the delivery process. This will be really exciting. So stay tuned until you hear from Ingo. Really excited to have you here. Thanks for coming. So this is how we'll go. We'll have, after my introduction, 20 minutes per speaker, roughly. Then we'll have to make a hard cut. We have a lot of topics to hear about today. Afterwards, after every speaker, we'll have a 5 minutes Q&A session. I'll pass around the microphone here in the better space for you guys joining online, you can use the chat field in your stream to ask questions. And after we answered the first question here in the round, I'll get it transferred to a tablet here and read out your questions. So please type in the chat field if you have any questions. You can do this at any time, and glad to answer those too. Afterwards, after the fourth speaker, we'll just try to draft a summary here, the five of us, and that will be it. After that, we'll start our networking session here in the Better space. Last but not least, please make sure to sign up to our newsletter at bettermile.com so you don't miss the next last mile meetup and industry news. Also make sure to follow us on LinkedIn, where we also share exciting news about the industry. You really please use us as a platform, contact us at any time. We'll bring people together. We'll really try to contribute to this network. All right, again, thanks for coming. These were my words for now. Octavio joins the stage. Thanks for coming.
Hi, can you hear me? Hello? Yeah. All right, so thank you everyone. Great to see so many people joining us today. As Simon mentioned, we want to really start really building this community of people building last mile delivery services as a product, and this is really a topic that I really enjoy a lot, especially my topic, which is using geospatial intelligence. So we are building, or with optimizing delivery with geospatial intelligence. And I want to tell you a little bit more, not so much nerdy stuff, but maybe enough for you to know how complicated this really is for companies delivering parcels every day. This is our agenda for today, for this presentation. So how important geospatial data is. Probably most of you already know it, but let's just do a quick review of it. What's the threat from bad addresses? We see that there's a lot of really bad addresses coming in. Then we see how we are solving this problem with normalization and our journey of building this incredible technology. How we use geocoding also for the use cases for last mile delivery. And then we're going to talk about the future, the next level, what comes after that, right? So let's get ready. All right, so why is geodata so important for delivery, right? So there's a lot of use cases, but the real reason is because we want to create this exceptional delivery experience. And this experience is not just for the people who receive the parcel, it's for everybody involved. It's for the companies doing it, for the people delivering the parcel, for the people receiving the package. So we want to create this really great experience for everyone. And of course, we want to, optimize cost and time, right? We want to have really accurate position and everything. And this is why we are talking about this. So there are many different use cases for geocoding, for geographic data in delivery, but these are the three main ones: route optimization, real-time tracking, and delivery location accuracy. There are probably many, many more, but these are like the most common ones and probably the ones with the highest impact in this customer delivery experience, right? So with route optimization, of course, we want to be able to allocate what's the right sequence of stops for the drivers to go one after the other, to take the right path, the right street, to try to avoid heavy traffic and these kind of things. Real-time tracking, we want to give this nice experience to our, or to the people who receive the parcels so that they know when this is really coming in, not like in a time frame of 4 to 6 hours, but something shorter than that, right? And of course, we want the parcel to go to the right location. We don't want it to be delivered to a parcel shop, which is probably 600 meters away. We don't want to walk there and so on. We want to really get it in our doorstep. But geodata or geographic data has never been like the focus point, right? So it's mostly like been an afterthought on this industry. And there are many reasons, and I summarize like the three main reasons here as we rely, or these companies have normally relied in the driver's knowledge. They just pack a lot of parcels in a van, and they trust, they of course provide as much help as possible, but ultimately the driver's knowledge is what gets it done. It's the drivers going there, finding the right door, finding the right level in the building, knocking the right door, and delivering this to the consignee. Then we have a process of digital transformation. This has been already a topic for quite some time already, but we still see that this is really happening. This is a real picture of deliveries done really still today with paper, drivers getting all the list of stops that they have to do, and they even calculate the different zones that they want to do on paper. There's technology for this already. And they still are doing it like this. So this is really something that we need to change. And this topic was usually ignored because people were deep into the operations. From the last meetup, we saw, okay, this is really difficult and so on. So let's just focus our efforts on this. But now we really see the power of geo data. But how bad can it be, right? I mean, we get our parcels delivered. Yeah, sometimes we get them late or something. But how really difficult it actually is. I mean, this address data can be unstructured, misspelled. They can come with completely missing information, and there could be even new addresses. I mean, cities grow. There are new addresses coming in every day, and this data is probably not digitized yet. So to cite one of my teammates, he have over 11 years of experience working in geographic data, and he says, an address is information a human gives to another human about a location. True. The problem is, I say, that we suck at this. Simply as that, right? And this is the reality. So these are real addresses that we have processed. I mean, I cherry-picked some of them because they're funny and everything. But for example, the first one from Spain, you see the street name, the house number, but then you see information, hey, please deliver it to the doorman between 10 and 14 or 17 and 20. It's on the first floor to the right. And this, we humans understand, but machines, maybe not so much. Then we have more or less the same situation in the US, something similar also in Germany. And in Ireland, we see something really funny like, oh, it's the former gun store in Cork Balls in Ballincollig. This is a real address. I'm not making this up. Someone wrote this down to get a parcel delivered this in Ireland. So now imagine how a computer can actually just understand these kind of things. I mean, computers are, ChatGPT is smart and everything, but not every system is getting there yet, right? So what's the effect of all of this? So the effect of all of this is, of course, non-optimal routes. I mean, if you don't have right data, right accuracy, sorry, address information, then you cannot calculate the right and optimal route. That's simple. You can have the best routing algorithm in the world. If a few of the stops are wrong, then you lost everything. You spend more fuel or battery, and then your timing or the time that the driver spends delivering is completely off. Of course, that leads to wrong ETAs. Customers are not going to be happy. They're not going to get their parcels on time, right? And we want, or companies want to deliver the parcels in the first attempt. This is not going to happen that often if we don't have the right geographic information, right? And then the customers are like giving us this little middle finger to us, like, I want my parcel to be delivered on time, on the right location, but this is the address that I give you full of a lot of inconsistencies and things like this, right? I mean, with like, come on, just help me out here, right? And this is really what takes us to what can we do? I mean, this was the question that we had many years ago. Like, this is the reality. I mean, there's no way to change this. People are still going to be, really bad at giving addresses many times and so on. So what we figured out is that the data is out there. All of this address data is out there. Not all of it is digitized, and this is really the challenge, right? But the data is out there. So our journey started like, okay, let's try to find out how we start digitizing all of this knowledge and so on. There's a lot of data preparation that have to be done. It takes a lot of time, a lot of effort. It's not mostly manual, but very manual. And this produces what we call address intelligence. Like all of this knowledge about where the parcel or where the addresses are located, all of these semantics of where the address is or what the address means. So we came up with what we call normalization. I will not nerd down too much here because maybe we don't have enough time. But pretty much what this means with normalization, or what normalization is taking all of these many different variations of how people write their addresses and try to take them to the normal or standard way with normal values, with official values of the street name and these kind of things. So we do a lot of input preparation, so we remove characters, we maybe simplify things here and there. Then we use machine learning to actually identify, okay, in all of this text here, what is the street name? What is the house number? What is the postal code? What is the city? What is the locality? All of this information, right? And of course, machine learning for this is exceptionally good. Then we do component validation. Okay, is this value here really as it is? Is the street name really like Straße, STR, or many other different variations, right? Is the house number present or no? And so on. And then at the end, we do what we call similarity matching. So we have huge data sets, official data sets, private data sets, our own data sets, public data sets, and we try to match all of these different components to the right one. And what this does is actually something like this. You can take, this is of course an example, but it's real examples. You can take an address like this one. It's incomplete, it's wrong. And if you try to geocode it with Google, Google will not find it. But if you apply normalization to it, then you will get the right street, the right house number, and even the postal code, which was wrong because people just type their postal codes wrong sometimes, right? And then you get an exact location. And this is very powerful. This is at least one driver not having to figure out where this address is. This is a machine taking the driver to this location, and now the driver can do the best he or she can do, right? But obviously, initially, our idea was to reduce cost. If we have a lot of varied address data and we want to geocode it, we don't want to be geocoding just slightly variations of exactly the same address. We want to really cut this cost because the money was flying out of our pockets, literally, right? So we came up with normalization, we tried it out, and we tested it in real life scenarios. And then what we found was actually that normalization helps you solve this, but it increases accuracy in a big way. Accuracy and the improvements on address and geocoding information is literally a serendipity event in our journey. So we did want to cut our costs, but we found that we could cut our costs and increase the quality of the geocoding information when calculating where the address is supposed to be. And yeah, that takes us to geocoding. Hopefully, most of you know what this is, but basically, it's taking an address, hopefully a normalized address already, right? And it transforms it into, the lat longs, the coordinates of where in the world this address is located. And this is some very basic thing that we do every day when we pull up our phones and we use Google Maps and so on. And we as consumers, it works every single time. But when you deliver 1, 2, 3 million parcels per day, then the small errors and the small problems show up. And this is something that we wanted to avoid, and normalization helped us. Our current approach is working with partners. We are very proud to be partners of Google here on What 3 Words. We want to continue and extend our partnership with them. Our approach is that with all of this address intelligence, we now know who is the best provider for what data. We can know that we can use Google as a main geocoder in Germany, but in Ireland, for example, we are better off using here. And this is something that normalization enables, and this is something that this technology that we have developed allow us to do. And then you can optimize, okay, where is this parcel going to? This country, this city, this town, we know which geocoder we should use. And this is all enabled because of all of this work that we have been doing the last few years. And then geocoding is really, I mean, this is an oversimplification, of course, right? But geocoding is really address intelligence and huge data sets. Address intelligence to understand the meaning of this text that is it's supposed to be an address. All these different connections, this word means this word means that, this is the house number, this is an extension, this is not a postal code, and so on, right? And then match all of that to huge data sets of Laplons. And inside here is where a lot of the magic happens, right? It's a lot of things that we can do with address intelligence. And we realize that we are doing more and more of this work. We're doing more and more, we're blending this normalization or these address intelligence processes into geocoding, and we're able to even tell when Google is wrong. We can tell when here is wrong. We can. We can prove it, we have done it, we're testing it in several countries at the moment, and these have improved our geocoding accuracy tremendously. So it's this melt of all of this intelligence, manual work, normalization, multiple geocoders, and so on, that is allowing us to do this. But there's still a lot to do. This is the future, and the future is that there's still a lot of knowledge about addresses out there that we don't know. Recently, for example, one of my coworkers, she said, like, I've been inspecting this parcel, but I never get it right because I just move into a new building and the street still doesn't exist. She looked it up in Google and the street literally didn't exist. I have to go to OpenStreetMaps and I have to draw the street segment with my mouse so that this new street actually comes up into some map somewhere. But there's a lot of addresses that are not digitized. And this is what we consider to be the future, our next level. We want to bridge this gap. We want to bridge this gap on this world where address information is not sufficient, but there's still a lot of people who want parcels delivered. This is the Shenzhen area in the 1980s, 2011. I imagine that there have to be a lot of new addresses that still are not digitized. And this is what we want to do. We want to start putting together a lot of technology and people. We consider all of these as external sensors in a way, right? Our main sensor would be the drivers. The driver has a lot of knowledge. There's a lot of things that they know is in their heads that we can digitize. We now finally have the tools to be able to do this. We also have scanners, so whenever there's a scanning event, that literally means, hey, this delivery happened. This means something, right? It also sometimes comes with geographical information of where the delivery happened. And this can help us, for example, if we have an address that we could not geocode very accurately, if we get confirmation that it was delivered to the consignee, and at the same time we get some Laplons that might not be perfect, but can help us pinpoint the location, this is useful. Navigational patterns, what's the most likely or the best parking spot for the van? Maybe some street coordinates to navigate to the front door of the building and not to the side of it. And finally, there's a lot of sensors in all of these machines that we all have, and the drivers also have some of them. And we see that there's potential here for internal navigation, and our friends from Truemetrics are actually going to tell us a little bit more about it. We want to build these feedback loops, obviously, right? We want to use this address intelligence to guide our geocoding and our validation to send people to the right locations or not, and gather all of this sensor information and all of this manual input from drivers to create this cycle, this flywheel, to actually make this delivery experience even better. But we cannot do it alone. We have to do it together. That's why this event is so important, because the right people who are actually in power to make these things better, to collaborate, to talk to each other, can do it. So let's do it. So our technology is available for you guys to use. Just contact us. It is not open source, of course, because something have to pay the bills, right? But we're open to collaborate, to share ideas, to exchange information, and to create this, this new reality to bridge this gap. And that's it. Thank you.
Thank you. Thanks, Octavio, for this really exciting insights, and also some insight about the process. And sometimes you come across things that you didn't expect, and get great experience, like with higher accuracy instead of saving costs, but at the same time saving costs. So thanks for that. So I'm asking for questions now, 2-3 minutes. Any questions here in the room? And please, anyone joining remotely, please use your chat function now. Hang on a second, I'll come to you.
Hi, hi, I'm Reshmi. So my question to you is, for the feedback loop, do you ask the drivers for feedback after each delivery?
Yeah, so we are launching this feature with our customers, and we do try to tell the driver, hey, this location might not be the most accurate one. Please tell us where is this location. They can actually just drop the pin in the map. And we take in this information, and we apply this address intelligence to tell if this is something that makes sense. It's not just overriding the geocoded information. There has to be some intelligence behind it, because the driver might just put the pin somewhere else, 2 kilometers away, and we also don't want that. So we do and apply some analysis on this to correct it. So yes, the drivers can feed this back to us.
One more question here from the space.
Hey, have you done the math? How much it costs to you if a geocode, if a geocode is wrong?
Yes.
Can you share this with us?
No. But it's a lot. It is a lot, but I can tell you what it costs in terms of experience. It costs time to the driver to actually find out the location, so 2, 3, 4, 5 minutes. So do the math, how much you pay per hour to drivers, and then multiply that for how many drivers have this experience. I can tell you that around 3 to 4% of the addresses that we process usually come with less than accurate enough geolocation. So that means that 3 to 4% of, I don't know how many thousand drivers people can have in the company. For example, in the case of GLS Spain, it's literally thousands, right? How much does that cost? And if then you get a very high number.
Hi, I am here, Adam.
Hi.
Thanks for the presentation. I want to ask, what happens if a street name changes? What happens then?
Mm-hmm. Yeah, so this is part of what I call the address intelligence and the data sets. So there is, of course, a let's call it like a log of what are the different variations of the street name. And the different variations is not only that this person calls it John Fitzgerald Kennedy or John F. Kennedy or something like this, but also how the street was called before that. So this is kept into account, yes.
Okay, one more question. I don't receive any remote questions yet, but we can accept one more from the space here.
Hey, I'm Ben. Thank you. That was great. How do you compare different geocoders, and how do you also select what level of? You said you select geocoders for different cities or towns or countries. How do you select the right level of granularity for doing that?
Mm-hmm. Yeah, it depends. Each area is it's different, but you know that you have data sets about which street is in which area. You also know if the geocoder has performed well in this area before or not. And you also analyze, okay, is the result actually relevant? Are the components returned by the geocoder actually matching the normalized address or not? And then you kind of like do some magic math and you say, yeah, this is actually something that makes sense or not. You are never 100% sure that's true, and that's why these feedback loops are so important, because it helps us to narrow down the area or the exact location.
All right. Thanks very much for the questions. I don't see any question remotely. So we'll just hop on to the next speaker. Octavio, thanks a lot. Please give Octavio a hand.
Thank you.
David, all eyes on you.
Thank you. So, first thing first, so I would like to thank Bettermile team for this, to make possible all of this. Thank you everyone for sharing this time with us. So today we want to share some use cases that we can optimize the scale, the systems and the operational last mile operations, with geospatial data. So for those who don't know GLS Spain, and there is a lot of information here, but I will resume this information. So GLS Spain is just a parcel delivery company. But however, the business model that GLS Spain are proposing, are developing in Spain and Portugal is just quite different than the rest of the business model that maybe you can find in the most of the countries on GLS has activity. So at the end, GLS Spain are proposing a business, let's say a proximity-based business model combined with the powerful of the international network. So this is at the end bring us a clear competitive advantage. So today, GLS Spain is operating the biggest agency network in Spain with just in Spain almost 537 agencies right now. And the good performance during the last years are recognizing the GLS Spain as a good quality service, transport service. So at the end, GLS Spain is, as I said before, combining this proximity-based local business network with this international network. And the regional management provides us the delivery advantages that we can provide with this proximity network. And the regional management that we have in Spain bring us the opportunity to offer a highly personalizable or highly customizable offer catalog to the all customers, all kind of customers, because at the end, this kind of business model is for the big corporate customers, but for the smallest one as well. But yeah, at the end, we want to talk about the user experience on geospatial data. So as Octavio said before, the user experience is quite important because when we think on geocoding, when we think to geospatial data, when we think about to geocode, normalize an address, maybe we think on one of the use cases that Octavio showed us before is the live tracking experience. It's one of the, or maybe the most use case that the customers demands and the consignee expects. So for many reasons, the live tracking experience bring to the companies a lot of opportunities to perform a better operation, a better last mile operation, because at the end, we can prevent incidents because the engagement of the user, the engagement of the consignee on that kind of use cases are more efficient than another one. It brings us opportunities to throw new notification systems to perform this kind of engagement. So at the end, it's all about user experience. Yes, it's like the market is demanding this kind of user experience. GLS Spain has their own delivery experience based on live tracking services, notifications, specific applications, a lot of things to put the technology at the service of the user. But the user experience leads us to quality. So at the end, user experience is quite important, but we want to scale up our systems. We want to scale up our last mile operationals and system control and decision-making systems to provide or perform these last mile operations. So live tracking use case, it's not the only one that we can develop or implement in our companies with geospatial data. We want to talk about some of the use cases that we have based on geospatial data that maybe is not performing a consign experience, but impacts on the quality of the service that we have in place. One of them is link the driver devices to the delivery points that we have. So at the end, with a radius of this delivery point, we can manage the actions that the driver can manage with their own device. So this is quite important because impacts in many of our operational controls, because could be prevent the typical fraud, the fails absent fraud. We go through driver awareness about the operational rules because it's not allowed making certain actions on the device if you are not near the delivery address. This fraud prevention impacts on the customer service because if we enrich the track and trace service that we can integrate with the customers or we can show to the consignees, there is a lot of claims that we can avoid on the customer service. So at the end, safer operations that we can scale in an automatic way. Another use case that I want to talk about is the calculation about the carbon footprint in last mile. So depending on your environmental strategy that you have, it just needs some geospatial information that we can manage just with the real-time tracking experience. So tracking drivers, tracking the action of the drivers, geocoding the addresses, and just few data that we need to put in the profile of the driver, we have all the variables that we need to the basis of the calculation on the carbon footprint in last mile. But quite important is take advantage of any activity. Take in mind that any activity on your operations, it's just an opportunity to add value in your chain. So in this example, we can manage the compensation for, let's say, manage a zero emission last mile operations. And if you can add this value on every customer, you can take advantage of this kind of operation. But I want to share with you some kind of decisions or key values that we have on one of the process. This is the sorting routes and defining the sequence systems. So one of the most important things is consider stops, not addresses. We call waypoints, or jobs. We can call stops and delivery points, let's say. But at the end, you need to clusterize. Notice the density of the routes on your delivery. So at the end, it would be more efficient, and we can organize the sequence definitions in terms of stops, not in terms of addresses. So another thing that we can consider, at least for us, a very, very important thing is allow driver corrections. This is quite important for us because at the end, let them correct the algorithm, let them participate on the decisions on the algorithm. So at the end, it helps us a lot to break the acceptance barriers of the drivers that on that kind of system. So for our experience, there is a lot of effort, maybe more than the technical one, on the cultural change on the drivers. So if we let them participate on the decisions of the systems, allowing the corrections and taking into account these kind of corrections on the systems, the technology can be blended better with the driver, and there is a kind of better acceptance of this cultural change that we need to do with all the drivers. So yeah, of course, we need to rate, rank, categorize, analyze all the data what we have after the deliveries to learn about this as well. But more important than all of this maybe is which are the following risks that we have and how we can prepare the system for the new risks and convert them and turn into new opportunities. So add data, enrich the systems is one of the things that maybe we need to focus on. So let's take the electric charging docks locations as an example. So I think it was yesterday that the European Parliament declares that in 12 years there is no availability, won't be able to buy a car with a diesel or gasoline fuel type. Maybe 12 years from now it's far, far away, but the electrification of the fleet, it's something that it's happening today. So when we think about, okay, let's put the electric charging docks on the map, just as a point of interest for the driver, we need to do something else. It's not enough, because at the end, the driver will take their own decision, and there is no information on the systems to manage this time of charging, in which stop will they stop, as well, etc., etc. So we need to manage this kind of information to know in which electric charging dock the driver needs to be stopped. It's not necessarily stop on the first step, stop, because if we launch the tour on a 100% of battery, it's not necessary to charge the car on the first stop with a 99% of battery. But we need to know in which stop we will need to charge the battery. So it's just an example, but let's talk about restricted areas. It's quite important as well. All the city governments are ruling about restriction zones, walking zones, and whatever. So we need to connect or create these sources of information to manage this kind of information into the variables on the systems logics to define in which areas or which is the plan to make this route. Because it's not about just saving time or saving distance. The time restriction of the service, it's mandatory. It's one of the things that we learn. But at the end, if we want to keep this user experience, this ETA arrival on every service, we need to manage this new kind of situation that are a risk today, but we need to convert into into new opportunities to keep this competitive advantage that we have. And of course, another kind of example is the traffic forecast or actual traffic as well. So yeah, that's it. I was quite fast enough.
Thanks, David. Yeah, I think you made a major point. So also in future use cases, electric mobility will be definitely a core of it. But those who wanted to or who are trying to drive electric vehicles in the winter with -degrees, geocoding will not help us, unfortunately. No, just kidding. All right, so I will take a question here from the space and ask you guys remotely to fill in your questions in the chat field. Who wants? Yes.
Hello, hi, thank you for the talk. You mentioned earlier with all of these mergers and acquisitions you had, how do you manage to integrate the systems to solve all of this range of problems you've described? Because I guess you collect data from so many different sources and you use, let's assume, different services, different apps, different front ends, and how do you manage to collect the data in a central place in order to solve as many problems as you can?
Yeah, actually we manage these data flow pipelines of information with cloud services. In that moment, we manage these kind of things in Google Cloud Platform with data catalog, data platform. We manage a data lake warehouse in BigQuery, and we manage some use cases for visualization data into Looker or Data Studio. So we manage this kind of connectors and these kind of pipelines with just cloud products based on Google platform for doing that kind of purposes.
Okay, thanks. We have a remote question that says, do you already use location of chargers to instruct delivery drivers on best predicted charging intervals during the shift? The question is from Denis Kurilov from Routing Hub.
We manage this use case as a future one use case. So at the end, we are electrifying our fleet right now. So this is on our radar because at the end, it will be a lot of impact for our drivers every day, knowledge in which points they can charge this information. Hopefully with better route as well, we can get this kind of information.
Okay, any question here from the space? Yes.
Yes, thank you. Do you actively already calculate how long a driver takes at a certain stop, like a train station or something where he has to walk very far and calculate this into the routes? Or if he has very heavy loads, like mattresses or something?
No, we can deduce, but we are not calculating in a direct way as a time to wait or delivery time. So actually, we track the device of the driver every 5 minutes. So depending on the analysis of the positions every 5 minutes, we can deduce if the driver are waiting, delivering, moving, and how fast it's going.
All right. Any more questions here from the space? I would accept one more.
Thank you. You had mentioned the importance of driver feedback into the routes. How right now are you getting drivers to give you that feedback, or is that something that you've started, and how is it working if you have?
Okay, our first approach of get this feedback to impact on the decisions of the algorithm is based on a temporary window of behavior of the driver. So at the end, we start with a plan at the very first early morning, okay? This is the plan of the driver. And we have the real plan or the real actions that the driver has did. So then we have a comparison, and okay, one of the changes, there is no impact, because at the end, we need to wait. This kind of behavior, it's every day this behavior is performing a sustainable situation, let's say. At the end, this is known by the systems and taken into account for the next proposal plans for the same scenario, for the same zip code or the same delivery zone. But we need to manage the same situation repeatedly to consolidate the change on the system.
And how often is it that the route the driver actually takes is different than, or is not as efficient as the proposed route? You see the opposite happen.
Our approach, as I said, because we want to driver feedback. So our first approach is not push the driver to make the proposal of the system, because the driver has certain knowledge about the zone of they are delivering in many years that we can consider on the first versions of the system, because the system just know, okay, what is the time restriction, which is the distance, let's find a solution that respects the time restrictions, but with the minimum distance. So, but there is certain things that the only driver knows that could be happen and are good decisions, but are not digital solutions to be prepared. So for example, okay, the system is delivering for certain street, but the driver knows that in that hour, that street is a mess, because there's a school that it's the window, and this street is no longer available, and it's better avoid that street and turn on that street later. So this kind of behaviors every day mark the system decision at the end.
Yeah, I think we'll definitely at some point do a dedicated a meetup about this topic. This is really about the routing, the sequencing topic with all their constraints. And this is, I mean, we can talk about it for several hours. So it's a lot, and especially as you said, considering the driver's know-how in the sequence, and also, I mean, they are not robots; they are humans, and we depend on them, and we thank them for delivering the parcels. So it's also a matter of respect to consider their know-how and their wishes, right? So. But the groundwork definitely is the geolocation. If you have the wrong geolocation, the sequencing will definitely not be right. You messed up with the groundwork. Sure. So this is what we're talking about today, and hopefully we'll be able to make a meetup about routing dedicatedly. Thanks for the questions. Thanks, David. And Alex, it's your stage.
Yes, thank you very much. A nice warm welcome from my side to all of you here in the room and everybody who is with us on the screens tonight. I'm Alex, and I'm working for Hermes Germany, one of the bigger companies in the delivery market. And yeah, you already get two nice insights, really interesting insights of address data and geodata. So I might have a third perspective on this topic for you, and how we as Hermes look on this field and what we figured out and which experience we made. So the topic of my presentation today is what it means for us in the last mile delivery, the good and bad address data, and which effects it has if we do not have a good address data and a good location, and which strategies we do to help, which strategies can help you out of this. But before we start, let me give you some facts and figures about Hermes Germany. So we delivered, in the last year, we delivered more than 444 million parcels in the year, so this is more than 1 million parcels a day. So you see, we have a lot of delivery attempts every day, and in the last mile we work together with more than 11,000 couriers, and we have a really huge network of parcel shops in Germany, more than 16,000 parcel shops, which is really important for the returns and also for the C2C market for us. In Germany, we have more than 6,000 employees. More than 2,000 of them are working in the commercial sector. And we're also really international, although we are in the German market because the people coming from more than 19 nations. And we belong to the Otto Group, which is one of Europe's biggest retailers for the ones who does not know the Otto Group. And we could also say that we are the market leader in handling large items. These are not so, many others do not like them because of the handling. We do a lot of handling with large items as well. And I could say that we also focus on carbon footprint, on the reduction of CO2. So this is one of our top priorities for the moment. And we also do this here in Berlin. So you can see on the map that we already do emission-free delivery here in Berlin in many spaces. And we already deliver 2.5 million parcels a year in this segment. And we further develop and integrate new parts of Berlin city and also other big cities in Germany. So, and in this, it's also important that we find our customers and that we have good addresses. And it's also important for the carbon or emission-free delivery. And the question is, why is this so important? And why is this also important for us? The answer is, in the last mile, the key success factor is customer satisfaction. And so the customer wants to have the parcel at their defined places or their defined locations. And if you do not meet this customer expectation, then you will get higher complaint rates of the customers. You will see this in new delivery attempts, and the delivery costs increase, and also the customer satisfaction decrease. And so it's quite important that we know what the customer wants, and that the driver knows where he can find the customer and the location of the customer. So what means bad addresses in that case, and what is a bad address? You could say address is like you have the name, you have the street, you have the house number, you have the zip code, and you have the location. Then you can say, okay, it's a good address. And we have most of our addresses are good addresses. So, but there are also others which are not good addresses. So I point out some examples for you. And you could say, the house number is missing, or it's incomplete, like in the example, Karl-Marx-Straße, or you have a missing zip code, you have an incomplete name, and the fourth is you have an abbreviation in the street names. What happens then? Then you might have a problem because you do not find the location, but if you have a good geocoder, some geocoders can also transfer incomplete addresses and put the right location in that. But not all of these examples can be transferred into a good address. For example, if the house number is incomplete or is missing, there's no chance. So then you have to manually correct this. And but there are also, these are relatively easy examples, but there are also others, like for example, if you have the Max Vogel at Platz Republik 1 in 10557 Berlin, it looks like a really good address. Yeah, so you have you put it in the geocoder, and you get a GPS coordination for that, and the driver navigates through that geocoordination. But what happens is, if you put this into the navigation software, most of the navigators works with rooftop navigation, so it navigates you through the top of the building and not to the courier entrance. So you might solve some problems with a good geocoder, but not all problems, because even if you have a good geocoordination, you do not have a good delivery attempt, because there are some information are missing. Another example is you have the Max Vogel again. Maybe there are several of them, but this time he lives in the Karl-Marx-Straße, number 3, in 02991 in Lauter, which is a bit more east. And you also get a geo position, but is it a good one? At the first glance, you would say, yeah, it's a good address and you get a good geocodition. But here, the problem is that you have the same street name under the same zip code. So for the courier, what should he do? So he gets 1 point, but he will figure out whether it's the right address when he's at the doorstep. And it might be the totally wrong one. So, and this happens quite often in real life, because you have new incorporations, addresses changes, especially in the eastern part of Germany, you have a lot of incorporations, and this happens quite often, every day. So what can we do, and what will help us to improve the situation here? So I pointed some strategies, but we can later discuss on this topic furthermore, and you have heard maybe some of them, maybe some are new. So the first one is to point out the retailer checkout. So the online shops and the retailers, if they have a good address validation during the checkout process, this helps to receive good addresses in the full process. So what we do is we do some examinations on the retailers we have, and we work with whether we get good addresses or bad addresses. And then we see some of them have really good address validation, and you have really good level of addresses, and others is really poor, or some of them do not even have an address validation. So this is the first thing you should tackle to become or to get better addresses. The second one is we still receive parcels with manual written addresses on it. So if you have a C2C parcel and you bring it to some of our parcel shops, like especially the older generation, they write down the address of the customer manual, and then you have to transfer it into an automatical address, a system-readable address. And then you could use like optical character recognition. And the level of the OCR is important, how many failures you have later on in the delivery. So this is a topic we still work on to improve it, well, because we see that we still have this manual written parcels. The third one is address correction. What does that mean? So the bad addresses, where do they occur in the whole supply chain and in the whole delivery? When the parcels enter our line haul network, they will be delivered. Yeah, so they go on to the last mile, and in the end, the driver gets a bad address or a bad GPS coordination. And then what happens is that he cannot deliver the parcel and he brings it back. So you have got a return. And then you have to check the address on the parcel, and you have to find out what is the right address for the customer. So, and we try to build a new system on that, which helps us, or the guys who correct addresses, to be faster in that process, because we have many parcels going back because of wrong addresses. And yeah, the first one is geodata. So we also experienced with different partners here. And last year we launched a new navigation software, and there we integrated the geodata service of Here Technologies. So we made really good experience with them. We have heard in the previous presentation that they also used Here Technologies. And yeah, it's also important that you figure out which is the best geocoder for your surrounding and which helps us best. And yeah, for us in the last mile navigation at the moment currently, we are really happy to work together with Here Technologies. And the last thing is analytics. So what you can also do is, after the delivery attempt, you see on a map where the address is of the customer and what the courier did during his delivery attempt. So, and we built up a system called Last Mile Analytics, and then the people in the operational, they can check what happens on the tours, and they can see whether the courier is in the right place or he's somewhere else, and this helps us also to be better and become better in the part of geodata and address data. So what do we also do is, and what also helps us is to make the knowledge of the drivers available for us. So this is going to be the next level then for us. So because the drivers still has got the most knowledge in the delivery, the last mile delivery, because he knows whether the customer lives in the backyard or not, or whether he's at home and where's the best neighbor. So if you have this information available, you also increase the first delivery attempt, and you save costs and you get a higher productivity. And also important is to make the knowledge of the customers available. So you could put in some extra information in the address field, like yeah, is it the first floor? Is it the second floor? I want to have it as my neighbor. And if you use this as tool, then you also increase your delivery attempts, and this also saves costs, because if you have many returns and in the last mile delivery, and the driver has to search for the parcels, then it costs you a lot of time and also productivity. And we have heard in the introduction that productivity is key, and also the costs is important. So this is what we are doing and how we look on this area and this field of geodata and address data. And yeah, if you are interested in working with us, we are still looking for new talents. I have heard that some of the companies here have good talents, so if you like, you want to join, then you can scan the QR code and see what we are looking for. Thank you very much.
Thanks, Alex. Yeah, that was really exciting, and always new solutions and strategies pop up. I especially like the entry by the operational personnel, and so I would take the first question. Sorry,
you can.
So at what point do you do this? I mean, it will not do the depot manager by their own, but they need some local know-how, and it also takes some time. So what's your strategy behind it? At which point of the operational process do you request this information?
Yeah, in the last you call it in the last sub-depot. So when the driver comes back, then he, with a parcel, which he cannot return, which he cannot deliver, then he says, yeah, the address is wrong, or and then you can directly gain the information.
So it's an ex post correction. I'm kind of, okay, cool. Thank you. So I would take a remote question first. It is, do you allow your courier to augment your geodata by providing information, e.g., for example, door entrance, location, which is a big issue, for example, in the United States? The question comes from Hans Favre from Stuvo.
Can you give me the question again, please, because it was quite a long question.
So the question was if you are enabling customers to add additional information like floor or backyard, and how do you process it?
Yeah, we process it through our navigation software, and there might be still some lags that the information is not in the navigation software yet for every parcel, but we work on this field to integrate it more and more. And in the near future, it could be that you also get a text-to-speech engine where the driver, when he stops, that he gets a speech notice. You have to deliver it in the backyard. So you're at your stop, and then you receive this notification.
Yeah, that would be a great user experience for the driver, definitely.
Yeah.
I would take another question here from the space. Any interest? Yes. Oh, I had you already, so I'll go ahead there. No?
Thank you. Hey, I'm Ritus from Palmo. Very nice presentation, very clear on addresses. So my question is to another part of the presentation. You spoke about the emission-free delivery here in Berlin. Could you elaborate on if you have any challenges with that are new, just because it's emission-free, and particularly from a software kind of address-related point of view, if any?
Not from an address point of view, but more from an infrastructure point of view, because emission-free delivery needs a lot of infrastructure, like loading stations for the vehicles, and there are not so many available at the moment. And this is also really cost-intensive to build up and set up these infrastructure. So this is something we work on, but we need more solutions in a wider space. Also, like free available loading spots for our drivers.
It is a major challenge, I think, for all delivery companies, for all courier companies. And also the combination of different methods like bike, small vehicles, bigger vehicles, the zoning of it. So this challenge is definitely huge. We could do definitely one meetup about the electrification or hybridization of the route. I would take another question from Martin from Daco. He says, Alex, could you give an estimation on the incorrect address data quota at Hermes today in average?
No. I could, but I don't want to. No, I could.
Damn, I picked this question intentionally. I was also really interested in it.
No, I could give you a range maybe. It's if you say you have more than 80% of the address data coming in is correct. So you have like 20%, which is not correct, but of this 20%, you can correct
fix
some amount through a good geocoder. So there will be a really small amount of address data which cannot be correct automatically by a geocoder, and then you have to do it afterwards. But this is really cost intensive. We have heard that in the previous presentation, because the driver has to search and he's might be frustrated then. So it's good if you keep this amount really low.
Yeah, I mean, and this is again speaking as partners here, and the addresses are all the same.
Yeah.
So whatever delivery companies, they ship to the same addresses and they fight with the same challenges. And whatever 0.1% we are able to fix, it just saves a lot of money, and a good user experience, or you call it customer satisfaction. So I think you should definitely talk to Octavio.
Yeah.
Okay. So thanks very much, Alex, for the presentation. That was very insightful. Thanks a lot.
Thank you.
So now we're coming to the next level. Ingo, really excited to hear what you will tell us about location.
Yeah, thanks, Simon. Way to put on the pressure. And before I get started, I wanted to give a shout out also to Octavio for mentioning us. And I remember you promised that you wouldn't get too nerdy. I can promise that. So today I want to talk to you about algorithms for position and motion data. And you might ask yourself, why am I showing a surfboard on the slides? Fair question. As a startup, we often get asked, how do we come up with our idea? And that's where this surfboard comes into play. After exiting my last company, I spent quite a bit of time at the Atlantic Ocean coast in France and also did a lot of surfing. And that passion combined with my love for engineering made me ask myself the question, could I use all these sensors we have in a modern day smartphone to retrace the accurate three-dimensional curve of me surfing a wave? So I put my smartphone into a waterproof bag, put that into a 3D printed case, and fixed it to the top of my surfboard, and went into the water, tried to catch as many waves as I could, lost one smartphone in the process, and spent countless hours analyzing and processing the data to come up with the answer, yes, it is possible, but unfortunately it's quite complicated, and maybe a bit too complicated solely for this use case of adventure sports. But when I talked to David, who's one of my co-founders here in the back, about the challenges in food delivery and quick commerce around position and motion data, I thought, well, there is my problem that's worth this technical effort. And that's how Truemetrics came to be. We support the future for urban transportation and logistics with motion and position data that we create using sensor fusion and machine learning. We were founded in 2021. We're located in Berlin, actually just a 10-minute walk down the road. And we work with customers in quick commerce, food delivery, logistics, and we're actually just new to the space of parcel delivery, and we're happy to explore this space with our colleagues from Bettermile. Short agenda. I want to show you about the challenges in quick commerce and food delivery, and I think you'll see a lot of them are one-to-one transferable to what you've seen in parcel delivery. I want to show you one solution of ours, delivery location intelligence, to help make deliveries faster and more successful. And I want to finish off by proposing some opportunities for last mile delivery. But let's start with the challenges in quick commerce food delivery. These challenges are very near to our hearts because David, before joining Truemetrics, was actually an operations manager at Volt. So he experienced these challenges every day. And also, as you can see here, these companies are really struggling. The times of expansion at any cost are over, and now they have to start working on their bottom line. And to be able to do that, one of the major levers is efficiency in their delivery processes. And I want to show you two big challenges for this efficiency that revolve around position and location data. One is insufficient, unreliable data about the different segments of the delivery, and this data goes into dispatching optimization and performance management. Obviously, that's a problem. And the other one is significant delays in some of the deliveries when riders struggle to find the entrance where they need to deliver. But let's get into these in detail by looking at the journey of a rider in quick commerce. So you place your order in the app, and then in a dark store, in a logistics hub, somebody starts packing a grocery bag and puts it in a shelf. And at some point, a rider claims this order. He makes interaction in the app, and he takes the order off the shelf, and that's when the delivery process really starts. But he doesn't start to deliver right away. So he takes this bag, he puts on his gear, he walks outside, he needs to find his bike, he puts the bag onto his bike, and then he starts cycling. And this already can take anywhere from 30 seconds to a couple of minutes. And if we look at this quick commerce food delivery journey, that's a significant share in the total delivery, and a share that's currently invisible to companies that operate in this field. So the rider's on his bike and he cycles towards you. He gets to your destination, or actually he doesn't get to your destination. He gets to where Google puts the pin, and we've seen this before, right? So he gets there. He starts getting off his bike. He takes the bag, and then many providers require him to have an in-app interaction where he actually says, "I've arrived at the location." And this might actually happen right away. It might happen 30 seconds later, or it might not happen at all. The rider could forget, and I'm guilty of this. Testing our tech stack, delivering myself and food delivery and quick commerce, I've forgotten it. And what does this mean? The whole data set for this delivery becomes corrupted, unusable. But let's say everything went well. I walk up to the customer, hand over the groceries, and again, I'm required to do an in-app interaction where I confirm, okay, I've delivered. This happens typically fairly close to when I deliver, but again, it's a point of uncertainty. And this doesn't yet tell me when the rider is going to get back on his bike, and it doesn't yet tell me when he's going to get back to the depot, because he still has to go downstairs, get back to his bike, put on the helmet, start cycling, head back to the depot, and then when he gets there, he needs to swipe that he confirms he's available again for the next delivery. So what we see here is that we are lacking number of data points to actually describe the delivery process, and that the ones that we do have are highly unreliable. And that obviously becomes a problem for dispatching optimization and a problem for performance management. Because this unknown makes these companies built-in buffers in their process, and buffers kill efficiency. And looking at this process, I actually skipped a big second pitfall that I think we've heard a bit about today already. So let's say the rider gets to his navigation target where Google sends him or Mapbox sends him, but that isn't where the entrance is. And we've seen that in about 15% of deliveries, there is a significant delta between where a driver is navigated and where he actually needs to enter a customer building. Sometimes, you just turn around and it's a bit down the block. Sometimes it's around the corner. Or sometimes riders fail to find the entrance altogether. And this typically initiates a customer support call, and then we're looking at delays of 5 to 10 minutes. And that obviously is a killer in efficiency and time loss, and not a good customer experience. And today, I want to focus on this problem with you guys and on a solution for it. And to make it more tangible, I actually brought 2 real-life examples. On the right-hand side, super typical one, we get navigated to a street address, and we see this street address or this point is actually the entrance to a larger courtyard with numerous houses, right? So then we need to enter the courtyard and find where's the house that we actually need to deliver, where's the entrance where we actually need to deliver. Depending on the signposting, that can go fairly smoothly, or it can take a couple of minutes. And on the left-hand side, this is a more critical case, actually. Here, our navigation tool, and in this case, this was Google Maps, sends us to the closest location of where it has its geocoded pin, and we've seen that in the presentation by Hammes before. It's in the middle of a building, and this building is in a back courtyard, and the closest point to it is the parking lot right next to it, without an entrance to that compound. So I'm at a dead end. So here, very likely, we're going to see a customer support call that helps me find out where the actual entrance is, which is at the front of the street. And I would like to show you a solution to these problems. And we call this solution delivery location intelligence. And what we do is we automatically record and log into a database information about our delivery location. Most importantly, entrances, just talked about, but also which floor does the final delivery happen at, and where stairs or elevators are used to get there. And now we're going to get into the nerding out. Let me tell you how it works. At the basis of what we do is all the sensor data we get from the rider smartphones. This sensor data is collected by an SDK that is installed within our customers' front-end apps, typically called the rider app, the workforce app, and gets sent to our backend. And in our backend, we perform 2 steps. First off, we use sensor fusion to increase the accuracy and reliability of the position and motion estimate. And this is possible because we have different sensors in the smartphone that all have their strengths and weaknesses. So we all know GPS or GNSS. It's great. It gives us an absolute position on the globe. It has a bounded area, but it is prone to external disturbances. When I get close to a building, my line of sight is obstructed, my line of sight to the satellite, that position becomes bad and unreliable. On the other hand, IMUs, so accelerometers, gyroscopes, magnetometers, they're not affected by these external disturbances. But they only give me relative motion and they drift over time. But combining these 2 together with knowledge about the process that is behind it and that imposes boundary conditions, we can get to that higher accuracy and reliable estimate for position and motion, where our rider actually is, even if he gets close to a building. And our second pillar is machine learning to detect all the relevant events along the delivery process. And such an event, for example, is when a rider arrives at you, at your navigation pin, and he starts getting off his bike. But these events are fairly diverse because different riders act differently, different modes of transportation, different hardware. So to be able to do that accurately, we combine looking at motion state changes from cycling to stationary to walking, overlaid with the knowledge that we have about the process. So to give you an example, if I see that the rider is currently in a journey to customer segment and then goes from cycling to stationary to walking, then I know, okay, now I've switched to the next segment. He's actually going to the final stage of delivery, going to the customer entrance. And these 2 pillars, these algorithm pillars, come together in what we call delivery location entrance. Our machine learning models give us an exact timestamp at when the rider enters the customer building, and our sensor fusion gives us an exact location of where that is. And obviously that's helpful because if we have one of these cases where it's hard to find a customer entrance, if one rider, if one courier, if one delivery driver has solved that riddle once, next time we can route him to that entrance right away rather than to that pin in the center of a building. Unfortunately, or if you ask me as an engineer, fortunately, our algorithms don't have fancy user interfaces we can show, but we try to put together a bit of an illustration of the data to make this easier to get, easier to relate to, I would say. I'm going to play a video in a second, and it's going to be pretty fast. So I'll tell you first what we're seeing in the video, and then walk you through what happened afterwards. In the main viewport, upper left-hand corner, we see the point of view video from the rider who's delivering. Underneath, we see those motion states that are going to be changing as he goes through the process. Below that, we see the delivery process with different segments: order claimed, delivery started, arrived at customer. And the bottom right, we see a little map view of the location where he's delivering with a little pink pin of the navigation target that Google Maps gives him. So we see he's biking, and we're going to see him changing to different states in a second. So getting off the bike, going to walking, and what we're going to see happening is he basically graduates to the next stage of the delivery. So he's arrived at the customer, and he's now approaching the customer building. I'm going to let this run for a second and then talk about it afterwards. But you can see there's a door appearing on the right-hand corner. Goes into the back courtyard. Typical case for Berlin, we're getting a second door. So actually, I think it should end just about here. Yep. Actually, the first case was a tricky one for us. Because the typical case is that you sort of push open the door and you enter in a closed building, which gives us a very distinct event, but here we walk through a tunnel. So uncomfortable for us to detect, but still manageable. And then, as I already pointed out, typical data set for Berlin, I first enter the compound and then I enter in the backyard, which is great knowledge if I deliver to that same customer again, right? But also beware, be careful. Don't link that second door to the address because, depending on the customer that you deliver to, that second door might not be relevant. First door will be, second door, be careful with that. I want to show you a data excerpt of what the data looks like that goes into making these doors appear in our little animation here. So what do we see here? These are 2 position tracks, and one is raw GPS or raw GNSS, and the other one is the result of our sensor fusion algorithm. And if we look at the GPS, we see something that's actually quite typical. So, we're fairly fine in the beginning, we're going around the corner, but then as we actually are approaching the house where we want to do the final delivery, all of a sudden the track starts going into the other direction and then ends up in the middle of nowhere. Super typical for a GPS. We approach a building, we get more reflection signals, which actually turns what's happening around. We get less quality signals, so we end up in the middle of nowhere. And if we use this raw data track for pinpointing the entrance, our entrance again would be in the middle of a building, but in the middle of the wrong building. So on the other hand, you see what comes out of our fused location track, and we see here that by using these other sensors, by using the knowledge about the delivery process, we can compensate for those bad GPS data point. And you see the tiny little red dot there, that's where we ended up. It's not exactly where the door is, but close enough to make it worth it, right? And yeah, I think that's already it for my nerding out, but I did want to share with you some opportunities in last mile delivery that we just kind of want to pitch and that might be interesting for the discussion later on. So I showed you in detail a feature that we are using or that we've used for food delivery quick commerce, which I think is just as valuable for parcel delivery or any other last mile delivery, detection of entrances, but also other location intelligence like floor, stairs, etc., to make your delivery faster and I guess also more successful. I just briefly brushed on delivery journey insights, and this is this automatic segmentation of a journey into reliable timestamps to make dispatching and performance management more reliable and more efficient. And 2 other features that we want to propose that would be easily able with basically the same tech stack is what we call mapping parking locations. So same as we map entrance locations, if we know when a delivery driver gets out of his van and we know where that is, then we have a parking location. And what makes a good parking location, it's available, it's safe, it's legal, hopefully, and it's close to where we need to do the final delivery. And if you could share the parking locations of your experienced drivers with your rookie drivers, wouldn't that be great? Second one, we dubbed proof of attempted delivery. This is a tricky one. I don't know, I think we've all experienced this. We see our delivery status changing from waiting to a delivery attempt failed, even though we were at home all day long, waiting for our precious new iPhone. We just went out real quick to walk the dog for 5 minutes. So who's at fault here? Did that delivery driver really just skip me on his tour? Did he maybe, we talked about geofencing. Did he maybe drive past and say attempted but didn't even stop? Was it those 5 minutes when I wasn't there? Or is my bell maybe broken? Who knows? So to solve this conflict of accountability, if we have a precise and reliable location of where the driver is and what he's currently doing, is he standing or actually riding a van, when he's clicking that delivery attempt failed, we could maybe solve that problem here. But it's a tricky one. So those are just 2 ideas that we wanted to throw over the fence towards the crowd. And yeah, that actually brings me to the end of my presentation. I don't know if you guys are going to share the presentations in the end anyways, but if you want to snap a picture of the QR code, I'm going to be able to send you the presentation. And thank you.
Thank you, Ingo. That's amazing, because we talked so much about the how to navigate the driver to the rooftop or even a closer coordinate, and now it really feels like we in the future will be able to close the gap and the gap to the front door, to the right front door. So it's amazing. I would take some questions, first from the space this time. Any questions? Yeah.
Thanks. Yeah, great presentation. Really interesting. So just imagine one driver who's the first one at a specific address, doesn't find the address, goes to a wrong location first, and this is recorded. Afterwards, another driver follows this instruction and also goes to this location. I guess this could be a problem. So I'm curious on how do you correct yourself and the data that you have.
A good point. I think for this, you will definitely need the manual correction. But if you think of a parcel, it needs to be delivered at some point. And I think I would only, account for a location if a delivery is successful. I hope he doesn't go into the wrong location, just tosses the package and says it's successful, and then we're kind of lost. But if he's unsuccessful in an entrance that is recorded, then I would still want to record it. It's still interesting to know, but that should be a red flag. Like, don't try it there again.
I would take a remote question from Anna from Budapest. Do you record indoor events of the driver and create an indoor so-called turn-by-turn navigation, or is it just a static explanation? I would say just. Is it a static explanation?
I wish, but I'm going to be honest. If we could do that reliably, I'd be a billionaire and I wouldn't be here. This is like one of the biggest challenges, to do reliable indoor tracking and navigation without having mapped the space before, without any extra infrastructure. I think we're fairly confident of having a precise location of the driver maybe 30, 60 seconds after he's entered the building, but then things become fuzzy. So that's something we can't do yet.
Another question from the space here.
Yeah, thank you first of all. How do you match operational behavior to all this data that you have? Because you just mentioned you don't have your own front end, so there's not a driver saying, now I'm getting off my bike, now I'm entering a door, and I believe there must be hundreds or thousands of different data sets that you have. How do you do this matching of behavior?
Yeah. We're actually really comfortable in our little space of just being a data provider for position and motion data insights. So if you're my customer, I'm going to tell you, this is what happened. Go ahead and match that with your own data. You go and talk to the driver who wasn't there. Like, this is none of our business. But typically, to be serious here, of course, we have to take into account in what kind of databases our data gets injected. But in a classical case, you have an ID that's linked to a delivery or to an address or to a customer, and then we inject a new data set in that. Could be a timestamp that was missing before, could be a location that was missing before. But harnessing the data for efficiency improvements in dispatching, for performance management, that's really on our customer side.
And probably will be about the combination of those data and to create intelligence out of it. And that will be a really exciting field. Another question here from the space.
Thanks. That was really interesting. Do you have any issues with impact on battery, like the phone battery? Does it consume a lot of battery from the phone?
Yeah. So the trick here is to not record the whole time. If we were to do that, battery, we haven't seen as much of an issue, but also data, because through certain sections, we rely on highest possible frequency IMU data. And if we were to stream that the whole time, we'd really use up your data plan. So the key here is that we can use some simple metrics. For example, if I know I'm getting into a 250-meter geofence of the location, then I'm going to really turn up the volume, so to say. Then I'm going to really turn up the frequency. Then I'm going to increase the frequency on GNSS data, which is one of the biggest energy consumers. But for most of the journey, we can actually be fairly quiet. But there are some use cases where some customers might want to have the highest resolution of knowledge at the whole time. And then we haven't seen a huge impact on battery, but for sure it has to be accounted for.
All right, thanks very much. I would ask all the speakers to come to the front, grab a chair, and we'll have like a short sum up. Thanks, guys. This is David. Grab a chair. Maybe we need some space here. Yeah. Good. Ingo, thanks again for this look into the future. I will pass you around the microphone, so don't worry about it. As said, this combination in the future of the data, of all the events that we have and that we collect, that will be an amazing field. I want to bring up one topic that nobody of you guys brought up, and that's probably the elephant in the room. False positives. So, how do you guys handle it? And I just wanted to bring it up because it's when we don't know that it's a failure, we cannot handle it. It's very difficult to measure. And how do we deal with it? Octavio, let's start. I mean, you have some experience. Maybe you can also explain what a false positive is.
Yeah, so a false positive is when we have an address that seems to be correct, pretty much what Alex showed us in one of his slides. And then the geocoder say, it's actually here, but it could be that there's also another result that is relevant enough to show in this result. Then you end up having more than one single result. That's one type of false positive. The other one is, this is the result, but it's actually not the right location. So this is more or less false positives.
Ingo, do you also have something like false positives?
I think we just had one in the discussion with the question asked. Maybe not a false positive on our side because an entrance was there and it was detected, but it wasn't the right one for the delivery. And there we basically have to rely on the question if the delivery was successful. But still, we could have the case that an entrance is detected and it's actually, like we saw on the bad data. You know, nobody's proof from bad data, but we can do one backup check. And that's that entrances are typically at the edges of buildings. Unfortunately, for many of the buildings we have edge data available in mapping database, OpenStreetMap, etc. It's not available everywhere, but it can be used fairly reliably to check that entrance that I detected that is not on the top of the building, in the backyard, wherever. So those are two checks.
Alex, of those 80% that you said exactly right, you can validly geocode. Do you know how many false positives you have in that?
No. But I would say then it's people business, because you still have got the driver. And we work with the driver and we need the driver and we rely on the driver. And so this is really important knowledge, and we must take care of that and make it available in the systems, because I think that within the false positive, the systems comes to an end currently.
Which brings me to my next topic, which is the involvement of the driver. David, we heard also from you that you accept address corrections, and I mean, you have 5,000, 6,000 not only drivers but also geocachers out there. Have you planned any incentive programs for the drivers? Because this, in the end, this data is of big value, of course.
Yes, there is incentive plans to manage these corrections, because bad quality source information, maybe it's not allowed to geocode, or just to correct these false positives as well. So just like mentioned here, so involving people and drivers is one of the shapes that we need to involve and manage, this kind of like the false absent fraud, just to detect or audit how much is the difference on the geocoded address and the action of the driver. So at the end is a combination of all of this.
So I want to bring up another topic that was also brought up by you, Alex. This is the dependency to the shippers or the online stores where the actual address data is entered, which is a big challenge because, like, historically, parcel delivery companies, they just accepted whatever came in, right? They had to accept. It may be different with food delivery companies. They are in full control of the complete user journey, so they can check and validate the address whenever it's entered, and then at least you can probably say the rooftop coordinate will be fine. I just want to ask this question into the round. about the future of this topic. How also in parcel delivery, where thousands, millions of addresses come in every day, how to do the quality assurance from the very top, from the very beginning, from the shippers. What are the strategies of the delivery companies behind it? David, do you have any strategy like penaltying or anything, or incentivizing the shippers for address quality?
Yeah, it's a possibility because there is actual penalties for bad labeling processes on customers. So bad quality information, not about only the address, but the quality of the contact data of the consignee impacts on the user experience, because it's the way, the channel that we have to make this kind of experience. So yeah, this is just one of the activities that we can put in place.
Yeah, actually, it's a funny thing because there are heavy penalties for parcels that could not be delivered and have to be returned to the original shipper, and heavy penalties on it because it's a lot of additional manual work. But do you have any strategies of like creating other penalties that catch this problem on a more early stage?
I think you have to make it transparent to the retailers what the problem is, and then you have to speak about it first, because the penalty is quite a really hard issue you take in place, and the retailer also wants to create a good customer satisfaction in the end. So if he knows it and he has it transparent, then he really wants to work on it. And I think personally you can do it without any penalties if you make the problem transparent first, and then in the end, if it doesn't work, then you might take some penalties in place, but first you have to talk.
I mean, it is a common interest of both parties involved to get the pack delivered, and maybe it's also a matter of education, that how important address data is. But tell this to a shipping customer that has their ERP system and has the same addresses in there for the last 10 years to work on it. It can be difficult, right? So not every shipper is an online shop. So that will be a big challenge in the future. Ingo, you showed us today how to close the gap also for parcel delivery companies in the future. I'm really looking ahead to also to working with you and to learn. But you are very experienced in this field. Our dreams are high, but where are the limits?
I think one of the limits currently is that one question that was asked, indoor navigation. Also, I think from privacy standpoints, right? You want your shipper to arrive in the front of your building, but maybe you don't want a step-by-step navigation to insides of your building. I think it's good to keep this limit for now. But I think we can get so much better by sharing information. And I want to link to something that I think I saw Octavio post on LinkedIn not so long ago. You guys are all solving these questions every day. The food delivery companies are solving these questions every day. And if people have solved them before, wouldn't it be great if we could, access a common database? And I think there's really huge potential in that, because right now these things are solved by individual drivers, and then they're not going to make the mistake again. But the next driver on the next shift is going to make the mistake again, and the next driver from another company is going to make the mistake again for sure. And I think that can be avoided.
Yeah, I think that is perfect also for a closing. Partnership is the key. That's why we initiated here this meetup. We need not only to share information, we need to partner, we need to cooperate, because otherwise this data will get collected by others and will be out of our hands. So it is essential that we do this. Thanks everyone for coming here, making this again a success. I hope it was interesting for you guys.
Thank you for joining us on this journey through the Last Mile Delivery Meetup. We hope you enjoyed the exclusive insights and discussions shared during this podcast. If you are interested in finding out more about upcoming events, technological updates, and industry news, subscribe to the Bettermile newsletter. The link is in our bio. Thanks for listening.